This one.
Talk louder.
Yeah, but just be yourself.
Okay.
You go like this.
What we're going to do today is something called Kirchhoff's laws. These are problems with multiple batteries like this. It gets a little more complicated. The actual physics part of it's not that bad. The math part of it kind of is ugly because you have to solve multiple variables, multiple equations with multiple variables. The rules for this are, so the rules for Kirchhoff's law problems is the current into any junction. So a junction, I mean, like, you see where these three wires come together right here? That'd be a junction. The current going into a junction has to equal the current going out of a junction. And if we have a loop, like if we say like this loop right here, or this loop right here, or the big loop, so any like thing that goes all the way around and comes back, the voltage drops across that whole thing have to add up to 0. Does that kind of make sense?
Wait.
Give them the whole bunch of them. Alright, and in the direction of the batteries, push current from the small side to the big side. So you kind of, when you see batteries, draw a little arrow like that from the small side to the big side. It'll kind of help you visualize things. In a loop, so if the loop and the direction of the battery pushes the current in the same direction. So we're going to be drawing loops on here and currents on here. The direction we draw them doesn't matter. But if the loop and the battery are in the same direction, we have a positive voltage. If they're in opposite directions, we have a negative voltage. And then if the loop and the current are in the same direction, we have a negative voltage for a resistor. And if they're opposite direction, then it's positive for a resistor. Alright, so the best way to figure this out, guys, is to just go through an example. So first thing I'm going to do, should have drawn this bigger.
Your 70 and your 80 switched on the worksheet at least, if we're following.
Oh, it should be
yeah.
70
Yeah.
down there
70, yeah.
and 80 up there. Thank you. That would mess things up. Okay, so first thing I'm going to do, I'm going to draw currents going into this junction right here. I'm going to call this I1 going into that junction. And I'm going to have I2 coming out that way, and I3 going that way. So that means I2 is going through this top part, I3 is going through this bottom part, I1 is going through that middle part. And it doesn't matter what direction I draw those arrows, as long as at least one is going in and two are coming out. You can draw them this way every time if you want. So, because we said the current going in has to equal the current going out, we're going to say I1 equals I2 plus I3. Does that make sense? Because I1 is going in, I2 and I3 are going out. Any questions on that part so far? Okay, now I'm going to do the loop part of it. So I'm going to do this bottom loop right here, so this around here. I'm just going to draw a little circle, going like that. So we're assuming our loop is starting here and going around like that, clockwise. Does that make sense to everybody? So to do the loop portion of it, we do 0 equals. Then we kind of go through each part of that loop. So this battery, 70 volts V2, is that battery pushing in the same direction or the opposite direction of the loop? Same. So what's it going to be? It's going to be positive. If it was opposite, it'd be negative. Does that make sense to everybody? So we're going to say 70 volts. Now, this right here, what current's going through R1? I1, I2, or I3? I3. So, is I3 pointing in the same direction or the opposite direction of the loop we drew?
Opposite direction.
Opposite direction. For resistors, if the current and the loop are in opposite directions, they're positive. So that's on that rules, the rules on top of that. So it's going to be plus. And how do we find voltage if we have current resistance? IR. So we're going to say I3 times 27 ohms. Does that make sense to everybody so far? Okay. Now we're going around to the second battery, V1 here. Is that battery pointing in the same direction or the opposite direction as the loop we drew? Opposite. So you see how the loop's going that way? It's going around like this. And the big side's pointing that way. So bottom one, the loop's going like that, so the bottom one's pointing that way. Top one is pointing that way. Brian?
Did you just pick the direction of the arrows on the battery?
The direct guys, the question was, did I just pick the direction of the arrows? The answer to that is, I did. It doesn't matter what direction I draw any of these arrows. Everybody understand that?
So you'll get the same answer.
You get the same answer. You get different positive and negative values, but that's okay. Like for I1, I2, and I3, I might get -1 for I1. That just means I drew this arrow wrong and it's be 1 amp the opposite direction. So in these questions, all I'm going to be looking for is the absolute value of your answers. Okay. So again, why V1 is going to be negative here. Does everybody see that through this top part, the loop's pointing that way? And the battery's pushing current that way. So they're in opposite directions. Does everybody see that?
Yeah.
So because they're in opposite directions, when the battery and the loop are in opposite directions, you subtract. So this is going to be minus 80 volts. Any questions on that one? Okay. What about R2? Current's pointing through this is pointing this way, and the loop's pointing that way. So we're going to add or subtract V equals IR for 2. Add. So they're in opposite directions, so we add. So we do plus. That's I1 times 25 ohms. Does anybody have any questions about any of those terms, or why they're positive or negative, or why they're included? Next, we're going to do this top one. So there's a loop here, there's also a big loop around here. I only need to use 2 of them though. So I'm going to draw this loop like this. So we start off with 0 equals, I'm going to call this bottom, just so we keep it straight. Top. Okay. We'll start off with this battery. Is that in the same direction or the opposite direction as the loop? Same. So do we add or subtract it? Add it. So it's going to start off with positive 80 volts. This resistor up here, the current's going through it like that. So is that current in the same direction or the opposite direction as the loop we drew? Same. So what do we do? Subtract. So it's going to be minus I2 times 15 ohms. Questions about that one? Alright, what about the 25 ohm one? Is that the current through that one's going this way, so is that same direction or opposite direction as the loop?
Same.
Same. So what do we do with that one? What's that term going to be? Subtract, it's going to be which I? I1 times 25 ohms. Okay. Any questions about how I got any of those equations? Does that make sense to you guys? Okay. This is the physics part of it. Now it's math. Do you guys see what we're gonna do?
Yes.
How many unknowns do we have?
We put them
Let's
together.
do it.
3. We have I1, I2, and I3. How many equations do we have? 3. So we do 3 equations and 3 unknowns. If you want to set up like a matrix or something like that, you can do that with this. You don't have to. How I solve it is what I'm going to do. I'm going to solve this one for I2, so I'll get it in terms of I1, and this one in terms of I3, and then plug them back into this equation. So I'll have this equation with nothing but I1s. So first thing here, I'll do the bottom one. So bring it down to there. I use my board space as best I can here. Alright, so I'm going to rearrange this to solve for I3. So I'm going to subtract everything from this side except for the I3 term. So I'm going to get negative 70 volts. I end up writing small here. I apologize, people who are watching this video. Negative 70 volts. I'll erase this line. Just deal. Plus 80 volts. Minus I1 times 25 ohms equals I3 times 27 ohms. Okay, so I'm going to combine these two terms and I get 10 volts minus I1 times 25 ohms, and I'm going to divide both sides by 27 divided by 27 ohms equals I3. Alright, any questions about what I did there? Just the math? What I am going to do is turn this on to decimals so I get rid of the fraction. So you're just less likely to make mistakes that way. So I'm going to do 10 divided by 27. So we get 0.37 minus I1 times 25 divided by 27. Actually, I'm going to rewrite that as 0.93 I1 equals I3. Any questions about that one? Okay. I'm just going to erase this one so I don't have to like squeeze everything into the board. Do you guys all have this down? Should I give you a second? Everybody got that one? Okay. Now we're going to do the same thing for the top. I'm going to solve for I2. So I'm going to bring I2 over to this side, so I get I2 times 15 ohms equals 80 volts minus I1 times 25 ohms. So I just divide both sides by 15, so I get I2 equals 80 divided by 15, 5.33 minus I1 times, or actually let's just do this. 25 divided by 15 is 1.67 I1. Alright, questions about that one? Hope you guys wrote these down, because I'm not going to remember them now. Can I erase that part? Okay. Now we're going to substitute into this equation. So we get I1 equals, what did I2 equal?
5.33 minus 1.67 I1.
And what did I3 equal?
0.37 minus 0.93 I1.
Alright, so we add the two I1 terms to each side, and what do we get over here? So it should be 1 plus 1.67 plus 0.93. What is it, Kyle? 3.6 I1 equals 5.7. So what does I1 equal? 1.58 amps. Questions on how I found I1? And that's positive, so that means we chose the right direction for I1. Now we do the same thing for I2 and 3 with the equations we found before. So what did we say I2 equaled from before?
5.33 minus 1.67
minus 1.67 I1. So I2 equals what?
2.69.
And we got positive again, so that means we chose the right direction, so I2 is really going that way. And I3 we said equals 0.37 minus 0.93 I1. So what's I3 equal?
Negative 1.1.
Alright, so those are our three answers, 1.58, 2.96, and negative 1.1 amps. The negative 1.1 amps means that I3 is really going in the opposite direction we drew. The value is still the same, it's just the opposite direction. So on a test or a quiz or something like that, what I'd look for is that you have the absolute value of these three numbers. Because I'm not going to know which ones you labeled I1, I2, and I3. So as long as you have these three numbers, you almost certainly did it right. Kyle?
For when you make your equation, the top circle.
Yep.
I'm confused on where to use the I1 and the I2.
Like this top loop.
Yeah, where it's like I2 and 15 and I1 and 25.
Okay, so this I2 is that whole top branch. So I2 is the current coming out this way. So it's that whole top branch. And I1 is the current going through this middle branch.
Okay.
Does that make sense? So I1 is this whole middle branch, I2 is this whole top branch, I3 is the whole bottom branch.
Gotcha.
And again, it doesn't matter which way you draw the arrows or the loops, as long as you have one coming in at least to a junction. You can have two going in, one going out. You can have one going in and two going out. As long as some are going out, some are going in, doesn't matter which way you draw them. Loops, it doesn't matter which way you draw them at all. You can always do the current like I have up here and always do the loops like I have up here, and you'll always get the right answer. But you'll get the right answer if you do it the opposite directions as well. Brian?
It's a stupid question, but for like the I2, you have 5.33 minus 1.67 times I1. You have to plug I1 into that, right?
Yeah, so that's what I did here. I just plugged this value for I1 in over there.
This is making sure.
Right, any other questions? Okay, why don't you guys try doing number 2 on the back on your own. It's the same problem with different numbers, and if you feel ambitious, you can try to do number 3.
I just get some.